Before opening NTT PR IR Day, Mr. Ryuki Hoshino, Representative Director, Senior Executive Vice President, and CTO of NTT Inc., would like to say a few words and presentation toward the future with IOWN. Low-power optical computing for the IR era. Mr. Hoshino, the floor is yours. Thank you very much for taking time out of your busy schedule to attend our NTT PR IR Day today. I am Hoshino, Senior Executive Vice President and CTO of NTT Inc. The title of my presentation is Toward the Future with IOWN. Though our time is limited today, I will share with you NTT's initiatives on the future we aim for with IOWN, and our partner companies collaborating with us will give a wide-ranging talk on future strategies, product development status, and more, so that you could deepen your understanding on our initiatives on IOWN. In IOWN 1.0, APN and network have been pursued. But today, we titled our presentation to Toward the Future. So what we are trying to do under IOWN 2.0, the optical computing. Let me focus on optical computing. So the program was on the slide earlier. I will first provide the introduction on today's session, followed by Mr. Tomizawa from NTT Innovative Devices, spearheading the development of photonics electronics convergence, PEC switch, and leading collaboration efforts with other companies. And Mr. Anjin Huang, co-founder and senior advisor of IOWN Technology Inc., and Mr. Ram Velaga, senior vice president and general manager of Broadcom, who I mentioned earlier, will join us to talk about the outlook for the AI era from the global perspective, where we hope you will gain insight into the potential of the IOWN concept. And finally, our Executive Vice President, Ms. Onishi, will conclude by reiterating IOWN's role as the foundational infrastructure of the AI era. We will hold Q&A sessions in between, but due to the proceedings, the time will be limited, so we will hold an overall Q&A session at the end with President Shimada. So I hope we could ask many questions to deepen your understanding. So, although time is limited, I hope you could understand IOWN more. Now, under the title, Toward the Future with IOWN, Low-Power Optical Computing for the AI Era, I will introduce NTT's IOWN vision, focusing on our progress. We have many attendees joining us, including online participants, and we recognize that your prior exposure to IOWN varies. Some may have heard this a lot, and for some, this may be new. So I'd like to first take a moment to elaborate on the aspects I plan to cover in today's presentation. First of all, as you can see on the right side, APN, all photonics network, been focusing on network until now, But this photonics electronics convergence, PEC devices, and DCI, data-centric infrastructure, are also the components to use the computing in a decentralized manner. In the World Athletics, APN was used. We are starting to see some actual use cases. So the implementation is ongoing, but as I mentioned earlier, we are looking beyond towards the future. So this initiative aims to complement the limitations of electronic circuits like power consumption, speed, and heat generation with optical technology, and thereby supporting the next generation information processing infrastructure. In particular, we have discussed how photonic electronic hybrid devices can be leveraged to enhance the power efficiency of optical computing resources, which will be utilized more extensively than ever in the AI era. So this is my topic today. I think you've heard this many times, but data center and many power-consuming devices are increasing. We are entering such an era. With the growth of AI, we've said power consumption will increase, but we have not, the numbers differ. But regardless of the level, it is definitely increasing. Of course, the data center consumption is increasing, and AI market expected to grow 20 times compared to 2021. And so the implementation of new technology is a must. We've been saying this from a few years ago and been promoting IOWN. But now, other players are taking various similar actions. And our actions are in greater demand with the passage of time. So the general direction of the infrastructure is mainly twofold. First, reducing total infrastructure power consumption by controlling power consumption of networks and individual devices, and efficient infrastructure operation by making effective use of distributed infrastructure. Efficient infrastructure operation encompasses not only sharing resource for effective utilization, but given the current electronics power situation, we are increasing usage in regions like Hokkaido and Kyushu. By diversifying the location, we can pursue more green, renewable energy, reducing total infrastructure power consumption. You may know this, but in reality, AI uses GPUs, but GPU server contains not only GPU, but also CPU, memory, and storage. And communication is conducted, and GPU cluster functions as an assembly of multiple GPU servers connecting via high-speed switches. And therefore, with the increase in use, these communications need to reduce the power consumption. Photonics, the consumption does not change with higher speed, but with electricity, the communication frequency increases and the consumption increases accordingly. So the photonics was sufficient for long distance. Here, the horizontal axis is the transmission distance, and the vertical axis is the power consumption. The blue line, once the speed goes up, the consumption goes up with the electro. So within GPU servers, shifting to photonics will be a must. Now IOWN roadmap. IOWN 1.0 PIC 1. We've been using this, but in computer chips, more connections will be seen. So you see PEC 2, 3, and 4. So the package then combines. There are multiple packages on the board. The photonics was not on the board, but PEC 2. The PEC element is mounted on the board for connection. Now, in Kansai Expo, we had many use cases. Perfume and chokabuki, and remote production of Expo coverage for TV broadcasters. And IOWN computing is inside as well. Outside the NTT Pavilion, you can see the shading curtain. And with the people's expression and joy and emotion, this curtain waves. And this is realized with the IOWN photonic disaggregated computing, incorporating PEC switch. And this switch so the surrounding part, where you see the blue part, switchboard, the PEC device is attached. And ASIC, this narrows the transmission distance, and the electricity distance is reduced to reduce the power consumption. So before ASIC, the photonics engine PEC 2, NTT Innovation Device developed this, so he will come and talk later. This Innovation Devices, you may know the company. So NTT is incorporating these devices. AWG, splitter, and in this transmission diggable, we have pluggable package. And the guide and the devices to reduce the heat dissipation are developed. So this PEC part is developed by NTT Innovation Devices. So we will elaborate on this later on. And the other one, making this PEC switch, this box, and switch ASIC, and the PEC are combined, and the switch ASIC Broadcom, and the switch is made by Acton. So the two companies are here with us to talk about the potential of PEC 2 and the optical computing and the necessity thereof. We need to have this perspective and this knowledge. Lastly, going beyond, we will see higher speed. So now it's ASIC. We only need to connect to ASIC, but eventually we need to go inside. We need to have photonics inside. So PEC 3 is also being prepared. So we're preparing PEC 3. And we need to put this into the package so the chip is miniaturized and made very small. PEC 2 also, but as we compete with other players, the performance, the yield need to improve. So for PEC 3, we need to stay ahead of others. Now, the actual manufacturer, Innovative Devices, Mr. Tomizawa, will talk in more detail.